This is video 2 in a two-part series on significant figures. In the first video, I taught you the basic rules of significant figures. So let's just review from this slide quickly. A would have 3 significant figures. There's no non-zero digits. B would have 1, 2, 3, 4, 5 significant figures because the 0 digits are between non-zero digits. C would have 1, 2, 3, 4, 5 significant figures because the zeros are after the number and there is a decimal, and the decimal point is what makes them significant. Letter D would be unlimited because it's counted. Letter E, these two are placeholders, so we don't count them. 1, 2, 3, 4. This 0 here is between the numbers, so of course we count it. This 0 is rendered significant because of this decimal place, so this one has 4 significant figures. And lastly, this one, there's no decimal place, so only these two numbers are significant. It would have been far better to rewrite this as 9.8 times 10 to the 4th. So we've learned the rules, and if you forgot them, go back to the first video. Now we're going to learn rules that apply when we add and subtract. Now think about this. If I had 3 numbers and I wanted to old school add them, let's say I had 1.1 and I had we're going to keep these numbers super simple, 13 plus 1.112. Okay, and I told you to add those numbers. Now when you add those numbers and you look at them, you can see that this one here goes to the thousandths place. This one here, these two go to the hundredths place, and then all of them goes to the tenths place. And just like we always say, a chain can only be as strong as its weakest length, while a number can only be as precise as its least precise number. And what is my least precise number? It's this first one. This first one only goes to the tenths place. That means that my final answer can only go to the tenths place. So then I go ahead and I add this old school like normal, or you can use a calculator if you really want to. And when I do that, I get 3.342. And 3.342 would be the answer that you've been giving since you started adding. But now you know that since this number here only goes to the tenths place, this final answer can only go to the tenths place. So our final answer is going to be 3.3. Done. What if I had this number and then I told you to add these up? Well, once again, with just a quick glance, we can see that here's our weakest length. So our final answer can only go to 1 decimal place because we're adding, or same rule applies for subtracting. So when I add these up, and I'm going to be lazy and use a calculator, and when I add these up, I'm going to get 4.499. But I have to stop here because my number can only be as precise as my least precise number, and that's 4.499. But then now normal rounding rules apply. If I look to the right, that's a 9. So my final answer here is going to be 4.5. And you know, in your whole life, when you ask a teacher, what is it that you want us to round to? Well, now you know. Now the answer is answered for you with significant figures. Let's try this problem right here, B. 74.626. See how this has 3 decimal places? Minus 28.34. See how that has 2 decimal places? So my final answer can only have 2 decimal places. So get your calculator and work this one out. And when you do, you should get 46.286. And in the old days, you would have said to your teacher, what do I round to? But now you don't need to say that because you know that a number can only be as precise as its least precise number, which is this one right here. So I can only go to 2 decimal places. So that number gets to stay. That number gets to stay. Look to the right. Whoops, 6 is greater than 5, so I'm going to round up. So my final answer is going to be 46.29. So the rules for addition and subtraction are the same, and you're always looking at your decimal. All right, now what do we do with significant figures when we multiply and divide? Well, multiplication and division is used a lot more in chemistry because of the formulas that we use. So this is the one that students get the most practice in. And in multiplication and division, you're just looking at the total number of sig figs, and the number that has the least number of sig figs, that's how many digits your answer will have. You're not looking at decimal places anymore, you're just looking at total numbers of sig figs. So for example, this number here has 3 sig figs, this number here has 2, so your final answer can only have 2 sig figs. This number here has 3, this number here has 2, so your final answer here can only have 2 sig figs. Here's a division problem. This number here has 1, 2, 3, 4, 5. This has 2. Your final answer, again, can only have 2 sig figs. And then, just to keep you from saying 2 sig figs for the last one, this number has 3. This number has, these are placeholders, so don't count them. This decimal renders these significant, so this number has 3, so your final answer has 3 sig figs. So what I want you to do now is I want you to just work these out old school. So pause the video and work them out. Okay, so I worked these out, just used my calculator, and for this first one I have 2.567. However, I can only have 2 significant figures, so I have to stop at 2. I look to the right of the 5. The 5 has a 6 next to it, so that's going to round up. So my final answer is going to be 2.6. My next one, I am only allowed 2 sig figs again, so I'm allowed this number and this number. I look to the right of it. I have a 7, so I'm going to round up, so it's going to be 1.5. This one, I'm also allowed 2 sig figs, and I got this big long number, and sure enough, people would be asking me, oh, what do you want us to round to? You don't need to ask that anymore because the significant figures tells you. You're only allowed 2 sig figs, so it would be this one and this one. You look to the right, it's a 1, no rounding even needed, so this answer here is 0.29. And then this last one, I'm allowed 3 sig figs, 1, 2, 3. I look to the right, and the answer is 5, which will round up, so my final answer is 18.3. So you see, with multiplication and division, all you're doing is taking your total number of significant figures, and the one that has the smallest is what your final answer is going to be in. And you'll get to where this is second nature to you. So let's go ahead now and let's practice a few. All right. So I want you to do each of these. Now these are all addition and subtraction, so remember the rule for addition and subtraction. In addition and subtraction, you can only be as significant as your smallest decimal place. So this one would have to stop at 1 decimal place. This answer would have to stop at 1 decimal place. This answer would have to stop at 2 decimal places. This answer would have to stop at 2 decimal places. And in this one, you do what's in the parentheses first, stop at 1 decimal place, but then your final answer, there are no decimal places, so you can have no decimal places in your final answer. So I'm going to pause the video, and I want you to do each of these now. These are the answers I get. Let's look at the first one. I said I could only finish with 1 decimal place, so my final answer has to stop here at the 10th place, but if I look to the right of the 10ths, the 100th place is greater than 5, so I'm going to round that up. So this is going to be 35.3. Final answer, correct sig figs for addition. This number here, I could also only go to 1 sig fig, so this is my final number. But I look to the right, that's also going to round up, so this is going to be 33.3. Final answer with correct sig figs for subtraction. This number here can only go to this 100th place, so I'm going to have to stop my answer right here. I look to the right, that number does not round up, so this is going to be 69.23. Final answer, adding with sig figs. This number here can also have 2 sig figs. I look to the right, this number does not round up, so my final answer is 67.01. And then my last one, when I work this all out, I can have no sig figs in my final answer, so my final answer is going to be 98. Sorry, not no sig figs. I can have no decimal places. So remember, when you're adding and subtracting with significant figures, you always go to your lowest decimal place. So now we have a multiplication and division problem. Actually, both are in there. And if you remember your math, you learned PEMDAS. That means you're supposed to multiply before you divide. So we're going to do this first, and then we're going to divide. This is multiplication and division. So now you're using total number of sig figs. This number here has 3. This number here has 5. This number here has 2. And based on the rules for multiplication and division, my final answer can only have 2 sig figs. So let's go ahead and do that one. When I work this out, I get 23.2585737, and all the students said, Mrs. Arrington, when do you want us to round? Or what do you want us to round to? You do not have to ask that anymore because Sig Figs tells you where to round to. We're only allowed 2 sig figs in our final answer, 1, 2. So we're going to stop. We look to the right, and that doesn't round up. So my final answer here is 23. Done. Now let's look at this next problem. In this next problem, I have mixed math. I have addition and I have multiplication. So when you have that, you finish your first set and follow the rules for addition, get the sig figs for that, and then you multiply and use your rules for multiplication. So let's do this one. 74.3 plus 1.005. When you do this, you get 75.305, but this is addition, and I have 1 decimal place here and 3 decimal places here, so I can only have 1 decimal place in my final answer for this section. So now I take that number, 75.3, and I'm going to multiply it by 64.3192. I finished the addition portion, so I'm finished with my addition rules. And so now I go to multiplication rules. Multiplication rules say it's the least number of total sig figs. This one has 3, so my final answer can only have 3 significant figures. And when I work that out, I get 4843.23576, and I've got to round to 3 sig figs. Uh-oh, what am I going to do? Well, I could write it one of 2 ways. I could write it like this and not put a decimal there, or I could be really good and write it in scientific notation. This is the best answer. This one would still be marked correct though. All right, now let's go back and look at this mixed problem. What if you forgot about significant figures and you'd use this number to multiply by? If you had, you would have then said, oh, this is my least. I have 5 sig figs in my final answer, and you would have landed up writing this down for your final answer, 4843.2, and you would have been wrong. So be very careful when you have mixed problems that you finish the addition or subtraction portion, and then, or the portion in brackets first, and then you move on to your next rule. Let's look at this one, number 3. Number 3 says 74.3 minus 31. Divided by 41.4. So we're going to do this, this is in parentheses, so we're going to do parentheses first. There's no decimal points after the 31, so your answer, 74.3 minus 31, cannot be 43.3. It is 43.3, but you can't include the 0.3 because you can only be as precise as your least precise number. So now we're just going to say, let's just cross that all out. 43 divided by 41.4. It's a very interesting 3 there. And now when I look at this, I'm dividing. I have 2 sig figs here and 3 here. My final answer can only have 2 sig figs. My answer is 1.0386. I can only have 2 sig figs, so this one and this one, so my final answer is 1.0. Let's do one more and then we're going to stop. Let's look at this number right here. In this number here, I've got an addition in parentheses and then I'm multiplying. When I look at my addition, I have 3 decimal places, so my final answer for these two is going to be 3 decimal places. Now I'm finished with my addition rules. Now I'm going to multiply by 21. Well, what do my multiplication rules tell me? They tell me that I use the total number of sig figs of the smallest number, and this one has 2, so my final answer has to have 2 significant figures. When I do that, I get 1,714.146, and until today, that's probably how you left your answer, or you may have been scared because you didn't know where to round it. But now Sig Figs tells you, I can only have 2 sig figs in my final answer, so I can only use that number and that number. So I can't write 17. Heavens no, this is 1,700. So let's write 1,700 and let's not put a decimal there, and then those zeros at the end are not significant. But what would be the best way to write this? The best way to write this would be in scientific notation, and now your sig figs are very clear. No one's hunting for, is that a decimal there? Did they mean to make that mark there? None of that is happening, and this is your best answer. Okay, so let's go back to the PowerPoint now, and let's see if we're finished. We've already been rounding. We talked about operations. Here's a couple rounding practices. This one says it needs 4 significant figures. What would the answer be? 1, 2, 3, 4. Look to the right and it's 8. So this is going to land up being 626.0, because when we rounded the 8 up to the 9, that became 10, so we had to add on to that. So normal rounding rules. This one needs 4 sig figs and no rounding is going to happen, so it's going to be 625.4. All right, let's try example 1.1, uncertainty and measurement. In analyzing a sample of polluted water, a chemist measures out 25 mL water sample with a pipette. At another point in the analysis, the chemist used a graduated cylinder to measure 25 mL of a solution. What is the difference between the measurements, this and this? Well, this one is precise to the hundredths place, and this is only precise to the ones place. So this one is way more accurate, and that's why you would use a pipette, especially in something like titrations, because you want to have exact volumes. The quantity 25 mL means that the volume is between 24 and 26. Remember I told you that the first number is certain and the second number is uncertain, so that's implying it could be 4 or 6. Whereas look at the 25.00 number. The 25.00 number could be between the volume 24.99 to 25.01, so this one is way more precise. And that concludes our lessons on significant figures. I won't be putting up any more videos on them. There are plenty of worksheets available online. I will look for them and include the link in the description. Congratulations, you now know how to use significant figures.